Good day and welcome to the Math Saloon. Yeah, we're going to look once more at an advanced level question. This is about roots of quadratic equations. This may be the third video about this, but each time there is something new, so it's important that you take each of them seriously. You learn a new skill on how to tackle another type of a problem, still in the direction of roots of quadratic equations. The rule is simple. If we know an equation has roots, a quadratic equation has root alpha and beta, then you can form the equation by using the formula x squared minus the sum of the roots x plus the product of root equal to 0. Or if you know that a certain equation ax squared plus bx plus c is equal to 0, then you know that the sum of the roots is minus b on a and the product of root is c on a. Those are some of the ideas that we will try to put together to handle the problem given here. So the roots of the quadratic equation x squared minus x plus 2 is equal to 0 are given as alpha and beta. Prove that 1 over 1 plus alpha squared plus 1 over 1 plus beta squared is equal to minus half, and that 1 over 1 plus alpha squared times 1 over 1 plus beta squared is equal to half. Hence, form the quadratic equation whose roots are given by this. So it's simple. If we know this information and we know this, then we would get this because we know the rules for forming an quadratic equation given roots is simply x squared minus the sum of the roots plus the product of root equal to 0. And if we know this will be the sum of these roots, and so that's why hence come, because you use information that you already got previously. So let's start. So the most important thing is first to write our equation given to us. This is x minus x plus 2 equal to 0. We are told the roots are alpha and beta. In order to do that, we have to try to identify. Here we have a 1, and that is A. Here there's a minus 1, that is B. And this is C. So A is equal to 1, B is equal to minus 1, and C is equal to 2. So if I'm thinking about the sum of the roots of this equation, the sum of the roots alpha plus beta should be equal to minus B on A. B is minus 1, so this is minus 1. Because B, this is the minus from here, B is minus 1, I put that inside, divided by A is 1. So this is 1. Because minus 1 times minus 1 is plus 1, and 1 divided by 1 is 1. And the product of this root would be C on A. C is 2, A is 1, so this is 2. We keep that in mind. So we already know that our sum of root is 1, product of root is that. This is the information we know. This is what we'll be able to devise from here, to decipher from here. So if we decipher this from here, we will use that information for the rest of our work. So what we need now is, in any situation that we work, whether we are multiplying, dividing, whatever we do, the intention will be to be able to have things like alpha plus beta, alpha multiplied by beta, because we know that these are 1 and 2. So we will start with the A part there. So the A part says 1 over 1 plus alpha squared plus 1 over 1 plus beta squared. We look for the lowest common factor. The easiest way to look for the lowest common multiple, the easiest way to look for the lowest common multiple is just multiplying the 2. It will not be the lowest, but that is the easiest way when you don't know. If you want to waste time, you can start looking for that, but if you just multiply the 2, you'll be fine. You will get a common multiple, which will not be the lowest. So, but it will be okay. So that will be that. So if I take this, so this is just the product of this and that. If I take this and divide with this part force of this one remains. This time this gives me 1 plus beta squared plus. If I take this and I divide by this part force of this one multiplied by 1 remains. And this is 1 plus alpha squared. If we arrange that well, this will look like alpha squared plus beta squared plus 2 divided by, you can open this denominator as well. If you open that denominator, this will be 1 times 1 is 1. 1 times beta squared is beta squared. Alpha squared times 1 is alpha squared. Alpha squared times beta squared is alpha squared beta squared. So I have some information here, but that is not enough to already do. Here it's already fine. I can have this as alpha, beta, all that squared. That's fine. But I still have this part here. We've also learned about twice about completing the square method in 2 of my previous videos. The idea was that if I have alpha, for example, plus beta, all that squared, this is going to be alpha squared plus 2 alpha beta plus beta squared. See that? So that the only difference that I have between this is this term. This guy is hanging. I can take it to the other side. So I can say that alpha squared plus beta squared minus 2 alpha beta is equal to alpha squared plus beta squared. Then I have, so I just take this term to the other side. So it means I can replace all what I have as alpha squared plus beta squared with this. I can already, arrange this in such a way that it gives me, this is squared. Then, so that I already put the answers that I know I can do that, and then it will be simple for me. Or I can come here and play around here as well. So if I do that, I already see the alpha plus beta squared is 1. So 1 squared is just 1 minus 2 times alpha beta. So 2 times that is 2 times 2 is equal to alpha squared plus beta squared. 2 times 2 is 4. So that's minus 4. 1 minus 4, that's minus 3. So this is equal to minus 3. So I'm left now to substitute here. So this is equal to, here, I already have learned that by calculating that is minus 3. So I can put minus 3 plus 2 divided by, here under, I have 1 plus beta square plus alpha square is the same thing, it's just like that. So and the answer is minus 3. Minus 3 plus alpha squared beta squared is also the same like alpha beta or that squared. It's the same. And alpha beta is 2. If I square that, I get 4. So this is 2 squared. If I arrange this, I get minus 1 on top. I come below, I get 1 minus 3 plus 4. So 1 minus 3 is minus 2. Minus 2 plus 4 is 2. And that is minus half, according to what was required. So that's the proof of that. We will take the second one. So the B, let's have some space here. Yeah, we can. Think we have some space, right? So we can put B here. So we take this one here. So 1 all over 1 plus alpha squared multiplied by 1 over 1 plus beta squared. The numerators multiply, we get 1 divided by the multiplication of this denominator. But this is exactly what we already did before. So normally this will be 1 plus alpha squared, beta squared, plus alpha beta, all that squared. And we've already done that. And if you check, we did that here. This was 1 minus 3 plus 1, that is 2. So this is just half. So that's simple. Hope that one was fine and clear. The next thing is, now we are asked to form the quadratic equation with these roots. So we know that given roots, the quadratic equation will be alpha x squared minus sum of roots plus product of roots equal to 0. The sum of these two roots there, this plus that, is this, and that's minus half. So we get a minus half x, forgot the x there, plus product of roots. The product of roots are this one, that is half, and that's equal to 0. In order to make it nicely, so this is x squared plus x on 2 plus half equal to 0. We're in the salon, so this doesn't look beautiful. Before you go out of the salon, it should look nice. So we can multiply all through by 2, and I will get 2x squared plus the 2 multiply cancels this, x, 2 multiply cancel this, 1 equal to 0. So that is a quadratic equation with roots 1 over 1 plus alpha squared and 1 over 1 plus beta squared. Hope you liked it, and if you did, please share with your friends, talk with them, discuss, make sure that you prepare properly for your exams. Leave me some comments in order to improve, and most importantly, give us some thumbs up and subscribe. That's the only way I get to spread the information. I have some friends that I help with WhatsApp and so, but sometimes pasting this information all over the place is a bit much more difficult. Do subscribe, please. Have a nice day.